Welcome. You are visioning the recording of the workshop Monitoring Emissions from Space, organised by the SEEDS Consortium and which took place on November 28th, 2023.
My name is Isadora Jimenez. I work at Lobelia. I will be facilitating this workshop together with Thais Fontanell, that I will introduce her later. And now, 4 minutes after 10, I want to introduce you to Leonor Tarrazon. Leonor Tarrazon is Research Director for Environmental Solutions at the Norwegian Climate and Research Institute, also known NILU. She has 30 years experience on air pollution modeling, and she has contributed to the development of urban planning tools to secure better air quality and improve quality in Norwegian cities. And presently, she is responsible for the policy user interaction activities under the Copernicus Atmospheric Monitoring Services, also known as CAMS. Last but not least, I have already said, Leonor Tarrazon is the SEEDS project coordinator. So I give you the floor, Leonor, to use so you can make a short introduction to SEEDS and which are the final products that we have after 3 years in the project. So if you can share your screen.
So,
perfect.
I have it right. Perfect. Thank you very much.
You're welcome.
So, thank you, Isadora, and thank you all of you that are in the meeting today. It is a pleasure to show a part of the SEEDS project. It is a Horizon 2020 project on Earth observation, and we have produced emissions from satellite or constrained from satellite for the nitrogen, ammonia, nitrogen oxides, ammonia, and VOCs. And I really want to here acknowledge our colleagues at SEEDS. It is CONMI, it's Virra, Serfax, Meteo France, CNRS, and Lobelia Earth that is responsible there. The project has a goal to develop a series of satellite inversion techniques to estimate emissions and constrain the emissions of the nitrogen cycle and VOCs, and also to improve deposition flux modeling and advanced data simulation techniques. It is a project that began in 2021, and it was very much addressed towards Sentinel-5B in preparation for the Sentinel-4 instruments. And it is a part of the European Union's research strategy to really make sure that research projects can be in the evolution line for services, and this is the evolution of the CAMS, the Copernicus Atmospheric Monitoring Service. So we are now in the 3rd year, and we have a lot of information that our colleagues in Lobelia have developed. We have a very good portal. I say it myself, but it is really, it's something that you can see it as users, how it works, and that Pau Moreno from Lobelia will explain a bit later. What we have done really is put together a series of data, and just we think that putting the data there and making it available, having large data sets, and it is 4 years. Most of the data sets we have is hourly data, daily data with a very good resolution. The emissions that we are having is monthly anthropogenic emissions of NOx, ammonia, of fires, of soil NOx, and of VOCs. In addition, we have some flux data, Leif Area Index, soil moisture, and deposition for the same years, which is not the focus today. Today, we will focus very much on the emissions, and it is really to see what is the capabilities of those emissions from monitoring them from space that we have the workshop today. So the part that I wanted to show a bit is that this is under the Horizon 2020 evolution. The SEEDS project is part of CAMS, and CAMS is very well known, I think, already as a forecasting activity, providing air quality and atmospheric composition forecasts every day over Europe and in the global forecast too. It has a lot of downstream services. It's mostly for the forecasting, and it has emissions, and some of the emissions are both in the global scale and on the regional scale, but those emissions are not constrained by satellites. The data that comes at present has a lot of satellite data constraining the forecasting data that comes from all these satellite parts. So for ozone, for CO, for NO2, for SO2, aerosol, CO2, and methane, even the gas, the GFAS fire emissions are constrained by satellite, but not the anthropogenic emissions. That's what SEEDS it's about. What's interesting is that there will be even more new satellites that come with more information, and especially this Sentinel-5P and Sentinel-5 and the Sentinel-4 that we see. It's an evolution on the data that will be available from satellites, and that's what SEEDS it's about, try to see how it works and how it can be useful. What we have done in SEEDS is or what has been done in CAMS, it's really that we've seen improved forecasts of natural dust and forest fires with the use of satellite information. But as our colleague, and I think Jenny Stavrakou is in the audience today, she says there's still a lot of differences in the inventories of fires and fire emissions. And then the interesting thing about SEEDS is whether we can really constrain a bit more the type of information provided on the fires from the satellites and the use of formaldehyde. In SEEDS, the focus, as I said, is on the new satellites, and this is in the TROPOMI instrument. It's in Sentinel-5P, and the interesting thing with TROPOMI is that it has a very large spectral range. It has a large signal-to-noise, a very high signal-to-noise signal, high spatial resolution with 3.5 to 5.5 kilometers, and it has global coverage. This is really what then SEEDS is focusing on, especially on the part that has to do with formaldehyde and NO2. And then I want to show you that the data from satellites cannot be directly used. We need to have always an inversion method. And in the case of NOx and ammonia, the inversion method that we have is the inversion technique using satellite observations and a chemical transport model, which is called the DEXO model. And the products that we are using for NO2 is TROPOMI, and for ammonia is the data from CRIS. So the inverse modeling, this DEXO, which is developed at CONMI, and it's the daily emission estimates constrained by satellite observations. We have the CHIMER chemical transport model. We have a priori emissions and a priori or satellite observations. And then from there, from the satellite observations with the a priori on emissions, we use the model to get an inversion algorithm and get new emission estimates from it. The emission estimates then that then come are constrained by models and by observations. And it is interesting because it can be used, for instance, to analyze the time series. And one example of how we use it, which was very interesting, this is a power plant of Hemweg in the Netherlands. That was decommissioned at the end of 2019. And you can see this is the year 2019 to 2020. And you see especially the emissions from the DEXO inverse modeling with satellites from TROPOMI. In November, it drops, November 19. And you can see the very difference on the emissions due to the decommissioning of the plant. So it's a very effective way of checking if things are done as they should be. We have also had an interesting discussion with colleagues at the Barcelona Supercomputer Center, where they have an emission model done bottom-up it's the Hermes emission model that then we have compared with DEXO. And we've done that in Catalonia. And what it is interesting is that the results that we are having are very similar. In the total of Catalonia, Hermes says it's about 80 kilotons of NOx per year, while DEXO says 88. And we have the differences in summer and winter on what Hermes does versus what DEXO does. And what it is interesting is that comparing those with the different observations, we can see that in the difference that it appears to be the reason why DEXO is giving higher emissions seems to be the soil NOx emissions. So the natural emissions seem to be the reason for that. It was analyzed in 3 different areas where we see differences. You see the Barcelona area, a plant area in a specific Alcanar area, and the Girona area. And I'll go a bit in detail what we've learned from this intercomparison. In the Barcelona area, what was interesting is that they were very similar. The distribution also in time were very similar from the different bottom-up and top-down, which when we looked at what happened in Barcelona, we were sort of thinking that there is a good agreement between what we do from emissions understanding on the ground and the top-down estimates from satellites. So that was really for building up our trust in the data. And then when we got into the Girona area, what was interesting to see is that there were discrepancies between those, that when we analyzed then the seasonality of the data, this is the year 2019, and the different months, see that there are large differences between what we have in DEXO and in Hermes, even with the use of Megan data. And it seems to be the influence of the emissions from the agricultural machinery and the associated crop calendar that probably is not well considered. They have an idea on when the soil cultivation is, and it seems to not be correctly represented in the bottom-up inventory, the Hermes. So there will be a reconsideration of how the seasonal data is to be put in. So that's a very a case of understanding how the emissions from space can help us reconsider or reevaluate what we are doing. There's also so that not everything is so easy to understand. And we have a problem in an industrial hotspot in Alcanar in the Delta Ebro region, where we don't really understand why the satellite information provides such a low emission compared to what we know from the bottom-up inventories. So there are things here that we don't know if the errors have to do with albedo products or what it is the reason for this, and it requires some extra thinking to understand what are the constraints here. So it's really all the part on the satellites. The message I want to say is that it can be valuable, but really we need to consider it and evaluate it on the go and have the good understanding between bottom up and what the top down can be doing. In the case of ammonia emissions from satellites, it's again with the DEXO model, and we can see that the DEXO can give us maybe a bit more level of detail than some larger scale emission inventories like the HTAP can be done. This detail on some of the farms is not to the farm level, but it is a bit more. If the farms are very large, then we can see them. The interesting part is that we can compare and do benchmarking with different inventories. And what it seems to be is that it seems to be all right in many of the countries, but in Hungary, Ireland, Greece, we have very large differences, also in Poland, from the inventory done by Space, DEXO, and the ones that we have currently. So those are identifying of these outliers is something we can absolutely do with the satellites and understand why. The same that we did with NOx in Catalonia, we also did the monthly variations for ammonia. And there we saw a very nice small differences, but a very nice cycle with the understanding of the CAMS, Hermes, which is the bottom up, and the DEXO model. And then what was also interesting is that there are the seasonal variation or the monthly variation that we can have from DEXO is very different from what we have in other models. And when we put that into actual modeling situations where we see what it is, how the model performs when we are putting emissions from HTAP or DEXO, it's very interesting to see that in the summer months, the HTAP inventory is much worse than when we use the DEXO inventory. So it's interesting to see that in those months we're doing much better when we are looking at the emissions from satellite, which gives a bit of the possibilities of working with those. So some key messages maybe for the discussion today. We have this information available now from SEEDS, and we see that there are still things that need to be revised and understood from the emissions, but that there is a capability that for the location and the location of sources, the spatial resolution of Earth observation emission is still a challenge. It will not go to a farm level or a plant level yet, but it has possibilities locating the plants, and it's especially relevant looking at time series checks, verifying year-to-year variation, seeing emissions drop below different sets, estimating monthly and weekly variations. That can be a very interesting part, and most relevantly, it can help us identify some outliers, so we can see the reasons why we are where we are and how we are working with them. So it's really to open a bit the discussion today and to say that we've been checking that part, but we would like to continue checking with you and with your help. Thank you.
Thank you very much to you, Leonor. So after this presentation and seeing some of these results, one of the things that we want in this workshop is to give away things, to provide you with some relevant information. So first, then, let me introduce you, Thais. You have seen her. Thais Fontanel is an architect and urbanist. She's working as business developer and urban projects manager at Lobelia Earth. She contributes to innovative solutions to achieve urban resilience, and she's supporting Lobelia's mission of making climate adaptation and mitigation a reality backed by measurable evidence. So go ahead, Thais.
Thank you, Isa, for the introduction. Can you see the presentation?
Yes.
Yes.
Okay. So since we are here to discuss the potential role of satellite information to monitor emissions, we wanted to start the discussion by bringing a go-to-market journey for a specific air quality product to inspire you and help with the panel discussion later. But first, let me quickly introduce Lobelia Earth. We are a pioneer company producing and interpreting data for climate emergency. We use Earth observation data and climate projections for the creation of different applications in the face of climate challenges, including air pollution in our cities. And we are partners in the SEEDS project consortium. So air quality monitoring is relevant to different sectors, each with its own specific needs. And understanding these challenges is key to providing effective solutions. So advances in remote sensing post-processing and satellites like Sentinel-5P, as Leonor was explaining, have made possible the development of a top-down approach for estimating emissions from space. And through the SEEDS project, we are developing techniques to estimate European emissions, improve deposition modeling, and develop advanced data simulation techniques. But while what we achieve is very significant, we are also aware of the ongoing challenges. There are still gaps in addressing certain problems faced by end users, and it's essential to identify and bridge the gaps in emissions monitoring from space. So in various commercial applications, we are seeing great progress where post-processing of satellite-based data is being used to tackle end-users problems. For example, Lobelia Air, an air quality monitoring platform for urban areas, is providing information at street level, and is the go-to market example that we are going to be seeing here. So air pollution in our cities is one of the main causes of respiratory diseases, and vehicle emissions, for example, are common sources of air pollution. Many of the drivers of air pollution, like combustion of fossil fuels, are also sources of greenhouse gas emissions. And policies to reduce air pollution offer a win-win strategy for both climate and health. However, air pollution is often an invisible enemy, and decision makers need effective tools to visualize and quantify these issues. And also, citizens require better information about this health concern. However, there's a challenge. Many cities lack the infrastructure for detailed air quality monitoring. In-situ monitoring stations can't provide the granular data needed for effective local decision-making, and also official monitoring stations have a high cost, and many cities have a very limited number of these stations. There are global models based on satellite data like CAMS, producing a specific daily air quality analysis and forecast for the European domain, for example. Still, this resolution isn't enough for city-level decision-making. So how can we improve and merge this data, both from in-situ observations and satellite-based models, to create a product that truly meets the needs of city planners and residents? Lobelia Air optimizes the use of sparse data by integrating different sources of local data, such as traffic intensity, population density, and emission proxies with local sensors. And it merges it with CAMS data and in an atmospheric dispersion model. So the result is a platform that is able to forecast hourly air quality at street level. It informs on concentration on PM, NO2, and ozone. And this results in a continuous detailed map showing pollutant concentrations at every point across a city, providing information at the resolution that is relevant for city urban planners and citizens. Here you can see this continuous map with hourly information. Okay. But users also have access to historical data. A tailored application of Lobelia Air enabled the city to understand the average concentration of pollutants for every hour at every street segment over a typical year. And this specific product is being used for formulating effective low emission zone strategies. Another specific application of Lobelia Air was the assessment of average concentrations of NO2 in school surroundings. Considering that children spend a significant part of their day at school, high concentrations of outdoor pollutants can pose serious health risks. And by mapping this data, civil society was able to give visibility to the problem, resulting in actual changes to improve air quality around schools, such as implementing traffic calming measures in the nearby areas and promoting active transportation for commuting. Under the request of the metropolitan area of Barcelona, the platform was also adapted into a tool for everyday citizens. So it now helps people to choose less polluted routes for their daily commute, raising awareness about air quality and also promoting sustainable mobility. This shows that in some instances, the end product extends beyond providing direct air quality forecast. Instead, it's offering a practical solution by assisting users in choosing the best possible routes to minimize their exposure to pollutants. So these examples of bringing a product to market showcases the importance of understanding and addressing end user needs, as well as the transformative power of technology and data processing. So today's workshop represent an opportunity to bridge the gap between the scientific community and practical applications. And by bringing together diverse stakeholders' perspectives, we can think of solutions that are not only grounded in advanced technology, but also fine-tuned to the real-world requirements in different contexts. We can definitely use success stories like this to help us look forward to the potential role of satellite information to create solutions for monitoring emissions from space. Looking ahead, there are satellite advancements that could potentially improve our source data, like the upcoming missions of Sentinel-4 and DC-2M. Sentinel-4, for example, will provide hourly data of air quality in Europe, while current Sentinel-5 provides data once per day. And this is a big improvement in spatial resolution. And on the other hand, methods and techniques of post-processing that are being developed, like, for example, in our SEEDS project, to transform this data into actionable information are very important. So to finish my presentation, I would like to encourage everyone in the audience to consider the implications of these advancements in their own sectors, and to think of future possibilities regarding the potential of remote sensing in addressing global and local challenges. Thank you.
Thank you very much, Thais. So as you see, our idea here is to showcase, to open the mind, to understand that there might be products that are not feasible now, but that they could be answering one specific need, and this is what we are looking for. So which is the future? So we want to do an exercise of imagination and requesting and moving forward. But before we move to this discussion that is going to be with our 4 panelists, I would like to invite Pau to connect again, as he has now better bandwidth, and to show the data portal. Thank you, Pau.
Thank you. So as I was telling you, what we are aiming to provide with this data portal is a way, very practical viewer to let users easily discover the data and browse through the data. So that's why the layout is like that we are giving a lot of screen space to the viewer. And here we have the catalog, so users can browse from variable to variable very easily from the sidebar. And once we are looking at a specific data set, then we can look at the map and take a closer look at certain points, click anywhere to get a full resolution time series of in this case, this 2-year data set. We can zoom into the timeline and get more details about this specific history chart, like time series. We can also navigate on time using this bar here at the bottom of the viewer, and we can see how this line in the time series corresponds to the selected time here. I can zoom in and out as well in this timeline to get better resolution of the time that I'm viewing. I can also evaluate not only time series of given points, but we can also, for instance, evaluate the mean time series of a given area, and which is calculated on the fly, and it's again full resolution, and I can move the polygon, and I can see that the mean updates over time over this selected area that I'm choosing. So this is just a quick demo of the features of this viewer. Then not only we have the viewer, but we also provide details on each of the data sets published in the website. So that's why you can click on the information icon next to any of these data sets. I'm going to go get to the daily NOx emissions. And we can see here some properties of the data set, some URLs to download the data, again, some viewer. With the variable names here, we can inspect all the variables within the data set and some other description here. As for the data download, our aim is to spread this data as much as possible. That's why it's publicly available, and it's in this newish format, data format, which is JAR, which is cloud optimized. So it's really thought for be consumed from different application types. In fact, the viewer itself consumes the raw data, the JAR data, and renders the maps locally in the browser. that's why we offer this kind of performance that you are seeing. So if you want to download the data, you can click on this link, and it gives you some instructions on downloading the data using some Python code. We can really start. We can do a quick demo of that. So I can copy this code to to some notebook in Python. I can open the data set. I'm downloading it from the URL provided from the website, and then I can inspect this data set, and I can see that effectively it has these latitude, longitude coordinates and time coordinates, and then the variables that were listed in the viewer itself here, NOx and NOx alt. I'm going back to the code, and then I can maybe continue my inspection of the data and select this variable, the NOx variable, and select one point. For instance, 2018, 2019 for January 19, and plot the resulting map. And as you can see, I have the map here as well. So not only I can plot, but I can calculate. I can perform calculations through my data. So as you can see, downloading the data is quite easy. The instructions are already present in the web portal here in these pop-ups. And we even give some sample code to convert to maybe more. You can subset part of the data set and then put it on an FCF file locally and then work on it with different viewers. So using the data format, so all the data set within the seed portals are have more or less the same shape. The coordinate names are homogeneous across all the data sets. You will see latitude, longitude, and time. Time is represented the same in all the data sets. So yeah, we try to make your work as easy as possible. So we encourage you to try the data portal and give us your opinion. So that's it for me. Thank you very much.
Thank you very much, Pau. It was well and smooth. So I hope it was useful for all the participants. Play with it. You're invited to use it, compare it. Let us know if you use it for whatever, because this way we will know better what is being useful and for what. There's the contact email of SEEDS in case while you are playing or working with the data portal. If you have any questions, you can send your questions to that email. And now we move to our discussion panel. So I invite our 4 panelists. We have Michael Rodriguez that will be giving us the perspective on harbors and port cities. Hello, Michael. We have Montse Hernandez. She works in the Zaragoza City Council, and she will be giving the perspective of renaturing cities and urban planning. We also have Jose Antonio Clemente from ProDevelop in Spain, giving the perspective of harbors from the actual facilities. And then we also have Luz van der Net from RIVM, and more on the emission compilers and inventories. So hello, and thank you very much for joining us today. The session today we'll try to be as much interactive as possible, but we wanted you to have the opportunity to talk with the audience and explain a bit which is your context and why are you interested in satellite information for anthropogenic emissions. For this, we will start with a short presentation, 10 minutes each of you. So we will start with Michael and Montse, and then we'll have a few questions time. Then we will make the next 2 presentations by Jose Antonio and Luz, and then we will go for the broader panel discussion that will include, I tell you, participants, attendees. It will also have questions for you. So, Michael, if you want to start sharing your screen while I introduce you with more detail. So, okay, Michael, if you can try sharing your screen. Perfect. And Michael Rodriguez is a geographer. He's currently working as a postdoc researcher within the Faculty of Architecture and the Built Environment at the Delft University of Technology. And his research interests focus on web mapping and innovative approaches to visualizing spatial data and effectively conveying research findings to a broader audience. All yours, Michael.
Hello, everyone. Good morning. It's nice to be invited to be present in this webinar. My name is Michael Rodrigues. I'm a postdoc researcher working at TU Delft, Delft University of Technology. And here at TU Delft, we have Port City Futures, which is basically a collective of academics researching specifically port cities across Europe. And the dimensions are different: social, economical, environmental, but what they have in common, it's always the port city that's being researched. And today I'm bringing a case study from Rotterdam that I wanted to talk about in regards to atmospheric pollution, because port cities are one of the most polluted areas in regards to atmospheric pollution because of the emissions from the ships. And
Michael,
yes.
can you could share full screen so we see the slides full screen?
Oh, sorry.
No problem. That's perfect.
Sorry. So I was saying that the port cities are, in regards to health, they are one of the most polluted urban landscapes, not only because of the emissions from the ships, but because of the industrial areas that are located precisely because of the port. So port cities, they are basically interchange of population, flows of goods, commodities, and because of that, they also have an impact on the health of the city. Historically, we know that diseases have traveled by ship and they enter the port and then they spread inland. And after the Industrial Revolution, the port cities became one of the hotspots of pollution in regards to this webinar, specifically to atmospheric pollution. So everywhere, basically, where there is a port city, we can find, for sure, an hotspot of atmospheric pollution. However, the case that I'm bringing today is to raise some more awareness that we cannot only look at the data and say, okay, we have the findings from this set of data, and then that's it. It's not that easy, because port cities are also some of the areas with more available income or higher income in the city. So the access to better healthcare sometimes counterbalances the location of a given hotspot of air pollution, as I will show later on this presentation. So today I'm bringing the case of Pernis. Pernis is located in the southwest of Rotterdam, across the port of Rotterdam. Those that don't know, the port of Rotterdam is the main port in Europe, and is also an hotspot of pollution in the Netherlands. Pernis started to be a fisher village, and until the 19th century, when in 1902, the Royal Dutch Petroleum Company established a petrol storage and refinery in Rotterdam. It was located in Pernis. Then the company merged with Shell from the UK, the United Kingdom, and it created what is still today one of the largest companies in the world, not only in regards to petrochemical activity, but in regards to, in fact, into all the companies. There's one of the biggest companies still nowadays, Shell. And they, in the beginning of the 20th century, they located a refinery, which is still today one of the main refineries in the world, located in this area, in Pernis, in Rotterdam. So the city started to expand, also because of the expansion of the port. And over the years, Pernis started to be the built-up areas started to spread across the landscape. However, basically until the 80s, the main worry was about safety, and safety was in regards to accidents, industrial accidents, and not so much with air pollution. So only until the 80s we start talking about sustainability. So until then, the people were focused on the issue of the safety, and in fact, in 1968 there was a large accident in this location. And until the 80s, the importance was not so much on sustainability and environmental quality. It's more about the safety of the facility. However, after the 80s, we start talking about sustainability, and nowadays it's even more important. And in fact, because of all the industrial activity and also the ships that cross this area, Rotterdam is one of the unhealthiest cities in the Netherlands. And in fact, the port of Rotterdam is the most polluting port in Europe, by far. And we can see with the average age expectancy, in the Netherlands, it's 82 years. In Rotterdam, it's less than the average for the Netherlands. So it's lower, 80 years in the city of Rotterdam. Why is that so? Well, one of the reasons is because of the pollution that is emitted by the port of Rotterdam. So basically, the port of Rotterdam, it emits almost the same as 3 average coal-fired power plants together each year. So more than 14 million tons of carbon dioxide each year. And if we go to the hotspots of air pollution, and this is not from satellite imagery, this is from the stations, from the physical stations there that measure the atmospheric quality, and then they interpolate the data. So not from satellite imagery, but we can still see from the hotspots the locations across the refinery in Pernis, next to Rotterdam. And which brings to the question that if you analyze the data from the emissions, we must assume that Pernis, it's a very unhealthy location to be in because of all the pollution that is surrounding the city. However, if we go to the life expectancy, we see different results. In fact, Pernis, it has a higher life expectancy, not only in regards to Rotterdam, but even in regards to the average in the Netherlands. So we cannot just by the air pollution say that it is affecting the health of the people living in the city. It is, but however, we need to analyze other sources of data. So this was the case that I wanted to bring today, that the impact of health on the port is not bound to the local, but rather has to be investigated on a broader territorial scale. Looking at the singular homogeneous data doesn't give a clear answer to the issue. And we have an example here in this location, how the air pollution is affecting the people. However, there are other factors in place that don't have that much impact on the life expectancy as one should expect by only looking at the air pollution. So what we do in our research is to use mapping as a way to study port cities, as I told. So this is one book that we published quite recently. It's the Port City Atlas, which was an effort to map 100 port cities across Europe. So it's a traditional book when we can map and have different sources of data to understand all our port cities in regards to their sizes, to their flows, the commodities across 100 cities in Europe. Which brings to the evolution of the project is basically the geospatial platform. That's the word that I'm currently working on. So I work in the Bauhaus of the Sea Cells project, which is a large consortium of academic institutions in Europe. And they have a project, which one of the work package is the impact assessment of the measures that they are doing on port cities And the geospatial platform, which is done with open source software, will act like a big repository of all the research that is being done on the project. And on top of that, we aim to make available for anyone to do simple analysis. So to see how many people are living in a given area, if we want to know even municipality, or if we want to draw a shape or a buffer across the coast, how many people are living there. And then this brings to the atmospheric pollution, that we also want to integrate the source of atmospheric data from atmospheric pollution, so people will be able to see across the port cities in the project what is the pollution and how has the trend changed across the last couple of years for the specific port city in the project. So that's me. Thank you.
Thank you very much, Michael. Please, anyone who has a question, you can put it in the chat, but we will make the questions and answers after the presentation of Montse Hernandez. Montse Hernandez is a forestry engineer that has worked for the last 15 years as civil servant in Zaragoza City Council in Spain. Currently, she holds the position of head of the Office of Environment, Climate Action and Public Health, as well as being the director of the Zaragozan Forest, that I'm sure she will speak a bit about it. And Montse is also part of the team of the Zaragoza Climate Neutral City Missions. So, Montse, you can share your screen.
Okay, thank you so much, Isadora. Okay, good morning to everyone. First, thank you so much to the organization to invite us, to the city of Zaragoza today to be part of this interesting workshop. So thank you so much, especially to Lobelia. In the general context, Zaragoza is the fourth largest city of Spain in terms of population, located in the northeast of Spain between Madrid and Barcelona. Our work in environmental action today is in the context of the climate crisis. The climate crisis is the greatest socio-environmental challenge facing human societies. Zaragoza and the rest of the cities in Europe and the world have a crucial role to play in mitigating climate change, reduction of greenhouse gas emissions, and in adapting to the effects and impacts of climate change. So Zaragoza has designed different nature-based actions that sustain the city's climate action by committing to an ambitious strategy of naturalization and greening our city and its territory. So what is mean naturalizing? Naturalizing implies designing or transforming green infrastructure and opportunity spaces empty of connectivity through a management model and management oriented towards favoring the presence of natural processes, the spontaneous entry of flora and fauna, and boosting the generation of these ecosystem services without resorting to intensive management methods, minimizing human intervention. So green spaces regulate temperature, improve air quality, contribute to the physical and emotional well-being of citizens while providing peace and quiet and meeting spaces. They also generate an important landscape and aesthetic value in the city. The renaturalization of cities is crucial to respond to the effects of climate change, improve the health of their inhabitants, and recover biodiversity, aspects that will result in an increase in people's quality of life. In this roadmap towards the naturalization of the city of Zaragoza, there are two important areas of action that should be highlighted. And the first, the EU mission 100 climate neutral and smart cities by 2030. And the second one, the strategy of our city of connecting the city through nature. One data about the urban green heritage of Zaragoza. This is our dates in the city. So we have more than 13 meter surface per inhabitant of green areas, and more than 23 trees over 100 inhabitants. So we are thinking green. We are thinking to naturalize urban green spaces and to favor natural processes. So we need to improve our ecosystemic services of the green areas. So in related to the EU missions, in January 2022, Zaragoza applied for and was selected by the European Commission as one of the 100 climate neutral and smart cities, a recognition that opens the door to new European collaborations and support to reach the goal of zero emissions by 2030. In this sense, the EU mission aims to support the transformation of cities to accelerate compliance with the Paris Agreement and to be both a catalyst and driver for the implementation of the European Green Pact and a demonstrator that it's possible to achieve climate neutrality before 2050. Zaragoza becomes a European benchmark of its sustainability, mobility, energy efficiency, renaturalization, and circular economy projects, the so-called policies with the objective of achieving climate neutrality by 2030. In the key action of renaturalization and circular economy, the City Council is going to develop a plan for the geolocalization of green areas and forests in the city. The purpose of this plan is to be able to measure with the help of satellite images their capacity as CO2 sinks. In this way, it is possible to plan the necessary expansion of these green areas with the aim of achieving, among other things, a 5 to 7% reduction of the total emissions generated in the city of Zaragoza. To this end, the use of state-of-the-art technologies is proposed for use as analytical basis in the construction, elaboration, and monitoring of ecosystem indicators, among them the capacity of carbon sequestration and use the spatial resolution satellite images for use on analytical basis. So the possibility of immediate use of high precision satellite technology is integrated as a possibility for the automatic elaboration of inventory of vegetal species and elements associated with green areas, as well as for the automatic inventory of species and elements associated with green areas, as well as in the construction of terrestrial observations index, aligned with, for example, with the European project usage urban data space of Green Deal for the assessment of the health of the vegetative state in the municipal area, as well as the characterization of urban heat island phenomenon. In relationship of city greening project in the city mission, in particular the forest of citizens of Zaragoza and the restoration of one of the 3 rivers that cross our city are the 2 actions based on nature that support the climate action of the city as an ambitious strategy of naturalization and greening of the city and its territory. Zaragoza Forest City has the general objective to planting 100,000 trees and bushes by 2030, generation one of the most important carbon sinks at local level through a collaborative project involving companies, organizations, schools, associations, and citizens, greening and connecting the city and its territory. In the other hand, recovery of the urban section of the Huerva River. The project includes the ecological, urban, and landscape conditions of the Huerva River, and the objectives are ecologization, renaturalization, environmental actions, and connective the river with the city. These are some examples of the actions in the citizen forest of Zaragoza, and there are actions that we need to monitor to know what is the impact of these environmental actions inside the city. So this is an example of one of the most important actions in the urban city. And this is our infographics of the results of the action. And this is the river, the Huerva River in the heart of the city. And these are our actions to renaturalize this important area. So in the second big project of the city about renaturalizing our territory, we talk about the strategy that how can we connect in the city through nature. With the ultimate goal of creating a healthier and friendlier space for citizens, offering areas of greater comfort at all levels, the transformation of the boulevards with vegetation, applying nature-based solutions is turning into a bio-healthy route thanks to the reduction of noise and pollution and the improvement of the biodiversity and air quality. This innovative project is part of the strategy of connecting the city through nature, a strategy that involves the new management of the and design of a greener, a more sustainable and healthier Zaragoza with people in mind. The aim of the project is the renovation of the city's vegetation and the subsequent adaptation of the irrigation system to the new plantations, seeking an improvement in the reduction of noise and pollution and improving biodiversity and air quality. The intervention aims to improve parameters such as air quality, thermal and radiative comfort, biodiversity and biophilia through vegetation using species with the capacity to capture and fix suspended particles and gases. Species that help to increase the presence of fauna through their flowering and fruiting through the year, that improve the presence of different plant types, shrubs or different size, herbaceous plants and growth cover, as well as promotion at diverse and interest chromatids during in summaries, we need to find the ways to know, to assess the impact of our actions, to know if our actions are with these actions we are achieve our neutral actions in the climate action. So this is our work now in the context of the climate change. So thank you so much.
Thank you very much, Montse, for your presentation. And Michael, if you can also switch on your camera. We have now let's say a few minutes for questions. I see some from Leonor, but I'd like to start with you, Montse, because you have said in the two projects that monitoring this, evaluating the impact of the measures, it's important. Did you consider before using satellite information, or have you been monitoring? You're muted, sorry, Montse.
Sorry. We start in these actions in the context of the EU mission. So we have this portfolio of actions. So we don't have information before the actions. So we need to monitoring these actions along the time. So for us, it's very important to give the date and monitoring these actions to assess if we are taking the environmental objectives that we have in the climate action of the city. So we don't have information now, but we need information to assess our action in this subject.
Perfect. One of the things that is worth to highlight is that satellites are particularly good for assessing trends. Of course, we cannot go beyond having the satellite information, but is it possible to see temporal and trends over years, which is also probably one of the type of uses for satellite information to see if Zaragoza emissions really reach this 5-7% reduction that you're aiming for and see if it's achieved. Perfect. So I want to go with you, Michael. On this data portal, this exercise of providing as much information, which has been your experience with satellite data? Have you used it at all? Have you tried and it was too complicated? Which was your experience with satellite information for emissions or for other types of information?
Thanks for asking. So basically, I only had a look because we are not a startup, so we don't have that much resources. So we cannot do offline processing from the data that we want to use. That is why I had a look and I started to use interpolated data from the air monitoring stations across Europe because it's already done. So it's ready to use. It's much easier than to try to analyze and process satellite imagery ourselves. So, but in that regard, if the data is already worked and it's available, and it doesn't need a lot of offline processing, of course, it's much better to use something with high resolution. That's something that is interpolated and it's not very high quality.
Okay. I want to give the floor to Thais. I see some questions on the chat. I don't know if you want to raise any of them.
Sure. So there are questions from Leonor to Michael and to Montse. Perhaps we could start by asking Montse because she will need to leave soon. So question from Leonor is, can you please explain which satellite information are you planning to use for the mapping of vegetation usage project? Have you also considered biogenic volatile organic compounds emissions from this renaturing transition?
Yes, we are now we are thinking about what is a model we can use in Zaragoza to assess and monitoring the actions. So we are now investigation what kind of satellite images. It's really that we start to conversations with a company that use private satellite images because one of the key aspects of the use of the satellite image in the city is the scale. We need to collect information in small scales in the city. So we need images that can allow us to give us dates of small scales. So we need to work, as you say, Thais, before, on a street level. So this is one of the parameters that we need to consider in our work here in the city. But it's really that we are now thinking about the model and the source of data that we need to assess our actions in the city.
Okay, thank you very much, Montse.
Thank you very much. So I think we are going to move to the next two speakers to give their short presentation, and then we will move to the whole discussion with four speakers. There's also one question for Leonor later, but I keep it for the general discussions after the presentation. So now I would like Jose Antonio, if you can start sharing your screen while I present you. So Jose Antonio Clemente is a telecommunications engineer who has worked for the last 12 years at ProDeveloped Enterprise, the last 2 as project manager in research and development projects. And currently he is the technical manager of a new product where a digital twin is being developed will provide services, including the use of satellite images to monitor air and water quality in harbors. The floor is yours.
Thank you, Isadora. First of all, thank you for inviting me to this kind of workshops. And I'm going to introduce, as you said, my name is Jose Antonio Clemente. I work for ProDevelop for the last 12 years. Actually, I work as a research and development project manager, as a software architect. I'm going to divide my presentation in 2 main blocks. The first part is for explaining the status of the current situation that are in the ports, and the second part is for explaining a specific use case. In that case, the digital twin, that is the solution that we are developing at the moment, and we have included a module that is able to use satellite images to monitor the air quality and the different pollutants. First of all, I'm going to introduce my company. So I work at ProDevelop. We have 30 years of experience. We are the main provider of technology solutions in Spain related to the maritime sector. And our aim is to digitalize port and terminal operations. We work in all the Spanish port authorities, that are 28, in 4 regional ports, 2 national port agencies. One of them is Morocco, the other one is the Cameroon. So we are not only in Europe, also in Africa and South America. We are in more than 10 countries, and we work for more than 200 ports. This, as I said, I work in the research and development team of my company. So these are some of the projects where we have been working during the last years. If I had the opportunity to highlight some of any of them, could be this one, Eiffel, that has given us the opportunity to start working with satellite images. Okay, and now the first part of my presentation. So this is a paragraph that I have copied from the LinkedIn's description of the workshop. So here for me, there are 3 main keywords that are satellite data, air quality, and to craft solutions. Okay, for to craft, to elaborate, or to develop solutions related with the satellite data and the air quality, it is very important to know the status related to the digitalization in the ports. Okay, it's important into account that not all the ports has the size of Rotterdam, as for example has been commented by Michael. So I'm talking about small or medium ports. So if they don't have a very high state of digitalization, for them it is very complicated to develop their own solutions, to start working with satellite data that requires technical experience, and in conclusion, to elaborate this kind of solutions. Okay, it's important to highlight the different benefits of digitalization in ports. This, for example, could be the main 4 benefits for the port community. So it's something as, for example, myself, from a technological point of view, will try to explain to a port the different benefits. Could be the first one, the standardization, the second one, optimization, related with the waiting times, improved time KPIs. The third one is the profitability, so reduce operating costs. And the fourth is the future, so to be or to make more attractive the port for the future customers. But in the end, this could be that is very far away from the topic of today's workshop, but this is not the true. So imagine, in the end, there is a main aspect that is very related with all of these 4. So, and it's the digitalization encourages decarbonization, and this is related with the monitoring of air quality, and we have for that different options. One of them could be the use of satellite images. So the digitization encourages decarbonization. We have here two different points. The first one is the reduction of pollutant emissions, and the second one is to reduce or carbon foot reduction. This is, for example, the image that we can have in mind related to when we think in a port. So we have a very big vessel that is trying to load or unload their containers, and we have two cranes that are working in the port. But there are different aspects behind this photo. So for the vessel that is trying to, in that case, unload the cargo, for example, they are emitting pollutants to the atmosphere, and this has an impact, the air pollution. And the same thinking in the water. That could be another very important aspect related with the pollution. So the emissions to the water, their impact is that has effects or affect the marine environment. Okay. So what we can do to monitor this kind of emissions, in that case, I'm going to be focused on air pollution, but could be the same for the emissions to the water. In that case, was to monitor the wastewater or other different pollutants that could be in the water, as for example, chlorophyll, suspended matter, seawater turbidity, and so on. Okay, so as Isadora has commented, my company is working at the moment in developing a new product that is a smart port, but the main part or the core of the product is a digital twin. I think that most of us know what is a digital twin. Is in the case in a port, is a tool that provides a virtual representation of a port and their operations. It's able to collect data from different kind of data sources. So this is important, not only sensors. Now we will see that it is possible to integrate satellite images or other different data sources. We are going to show information, real-time information, historical data to show different charts or visualizations, or even we can calculate predictions. We can use for that predictions satellite images. And the idea is to replicate the port situation, and this tool could serve as a support decision tool. Okay, here on the right, we have the different models of the digital twin and how it's their relation. Okay. Okay. The digital twin, as I said, is on their basis, or in the top layer, has a smart port, and depending, the smart port is like a horizontal platform that has different services or vertical services. Here we have the smart lighting, security, energy efficiency, traffic management, multimodality, to monitor the port operations, and so on. But in that case, for us, it is very important, the environment. How we can monitor the environment? Using IoT sensors or using satellite images. And with that, I think I close the loop, and going back to the beginning. So the role of the satellite images to monitor the environment. Okay, so after the time that we have been working with that tool and the development, and it's something that is not finished. We are working on improve the product. So what are the main benefits? And it is very important for the ports. It's something that is free, the use of satellite images. I am talking about non-commercial satellites. So the ones that are free, as for example, has been commented, CAMS, so CAMS, the Copernicus Atmosphere Monitoring Service, or for example, the use of Sentinel-5P, Sentinel-3, Sentinel-2, 1, 4, and so on. Another benefit could be that allow measurements to be taken where it is not possible to deploy sensors. It is very important for the ports. Imagine that there is a big zip line that, for example, join in the Balearic Island, the port of Ibiza and the port of La Sabina. So it is not possible to deploy an IoT sensor to know the way the ship is emitting pollutants to the air in the middle of the sea. So the only option to monitor that is the use of satellite images. Okay, probably not the only option, but the most easy could be that. Okay, what are the main disadvantages or the areas that have to improve in using satellite images? Okay, the first one is the coverage. So not all the the areas are covered by the satellite images. The second one is the spatial resolution. So most of them has a very good spatial resolution, but other one, imagine, for example, Sentinel-5P has been commented that is 3.5 per 5.5 kilometers. So imagine that we are trying to explain the use of satellite images in a very small port. Could be the size of the pixel even bigger than the size of the port. Okay, so the third aspect could be the data frequency. Most of satellites has a daily basis image, so a image per day, but other could be 1 per hour, or there are other options that has 1 per month, or so it's something that has to be improved. The last option, and it is very related with the SEEDS project, because you have now deploy new products. So it's the products available. So imagine that, for example, the port wants to monitor a specific product that now or at the moment doesn't exist in the catalog of the different options of satellite that are. So it is very important to increase the catalog with new products. Now, for example, this is a picture from our digital twin. It is something that, in that case, it's a 2D map. It is when the people think about a digital twin, people think in 3D, but it is not important, or depend on the information, could be very or could be more profitable to have the representation in a 2D. So in that case, we are showing a specific satellite image for soil pollutant in the Balearic Island. We have the specific value in that pixel. Okay, here we have the same for other pollutant. In that case, is PM10. This PM is particle matter. Here, this is the same bounding box, so the Balearic Island, but in that case, using Sentinel-5P. Here we can see one of the biggest disadvantages, that is the coverage. Why the north area of the island, it is not covered by the satellite? Because there are 2 ports that are not covered, that are Alcudia and Palma, because the Balearic Island or the Balearic Port Authority has 5 ports. Okay, other use of satellite images that we are using, or a tool that we have developed within the digital twin, is to monitor or to calculate the air quality index using satellite images. So the sensors that at the moment has the port are not measuring air quality index. I don't know if you are expert on that, but this is a compound index of 5 pollutants that are PM10, PM2.5, sulfur dioxide, nitrogen dioxide, and ozone. So using satellite images, it is possible to calculate that index and to know which of these pollutants it is the ones that affects more at the time to know the specific value of the quality index. And that was all. And this is the last slide.
Thank you very much, Luis Antonio. Now I invite Luz van der Net, if you can start sharing your screen. Well, I present you, and as you see, we have tried to bring diversity of voices. So with Montse more on the practitioner side, Michael's research, but very broad perspective of cities, while Jose Antonio and now Luz are other type of stakeholders and users. So Luz van der Net is a chemical engineer working as an advisor in the group of the emissions registration at the Institute for Public Health and the Environment in the Netherlands, RIBM, the acronym. She leads the project regarding the annual submission of the Dutch greenhouse gas emissions inventory report of the Netherlands, and thereby fulfilling the reporting requirements on the governance regulatory of the Energy Union. So the floor is yours.
Yes, thank you for the invitation. I will tell you a little bit of the verification of emissions from the inventory perspective. Yeah, so we have the Dutch emission inventory, and I don't know if you're all aware of it, but what we do is every year the ER, which is the emission registration in Dutch, we deliver a set of emission figures from 1990 to the present, which is in line with international guidebooks. So let's say, for example, in 2024, we will deliver emission figures from 1919 up to 2022. So it's always lagging a little bit behind. And we delivered these emission data for international reports. So we deliver an international report on greenhouse gases and also an international report on transboundary air pollutants. So it's in the law that in the Netherlands and every other European country needs to deliver these reports every year. And we also have a data portal which everyone can enter and is available for everyone. And there we present not only the emissions of the greenhouse gases and transboundary air pollutants, but also for other components such as heavy metals, pesticides, and substances of high concern, for example. And we do this not alone. We work together with some other companies and institutes in the Netherlands, like the Statistics in the Netherlands, the Wageningen University, and Deltares for the water emission figures. But we, as the National Health Institute in the Netherlands, we have the direction. We are the direction of the consortium. So how do we do the emission calculations? We have two types of emissions, which are the point sources and diffuse sources. And for the point sources, these are registered via electronic environmental reports. So more than 1,000 companies in the Netherlands, every year they deliver their emission figures. And these ones are then registered and checked by the local authorities and also checked by us. And then for the diffuse sources, like let's say agriculture or traffic, for that we normally use a formula, which is the emission factor times the activity data to calculate these sources, in which the emission factors are based on measurements mostly, and activity data is mostly statistical data. So in the emission inventory, we have these two types of sources on a very detailed level. And we call that a bottom-up approach to calculate the national emission totals. And so far, we do not make any comparisons with top-down methods like satellite data so far. But of course, we see that there's a huge potential in the use of satellite data to estimate emission figures for countries. So we have interactions, and we are involved in some different kinds of projects. And the first project we were involved in was the Verify project. The Verify project is an observation-based system for monitoring and verification of greenhouse gases. And we see this project as the first step on a common journey with all other countries to make use of satellite data for let's say these international reports and to compare with the emission inventory data we have. The advantage of this project was that we got information and satellite data for a long time range, all the way back to the year 2000. So in the upper right picture, you see the emission data from the Netherlands starting in 1919. And then in 2000, there we had the data from the satellites, in this case for CH4. So it was nice that it was a long time series, but on the other hand, it was quite difficult to check what the real emission figures are, because the uncertainties are quite large. So it's difficult to make the comparison with our data. And in the bottom picture, in the project, they also did regional inversions, and for that we see a very diverse picture. They use, so it's quite difficult still to compare with the data we have collected in the emission inventory data, and that's also because, let's say, for example, different definitions. Let's say if we take natural emissions into account or not. What are the requirements to take more steps forward? We think that collaboration between scientists across different kinds of projects, like the Verify project and also the SEEDS project, Avengers project, etc., is very valuable, and collaboration is necessary to create one scientific tongue, let's say the same mindset towards the inventories. And if there would be some more agreement over guidelines, that will facilitate easy adoption for emission compilers. So that would facilitate, let's say, to add a memorandum to the international reports where we can compare our emission data with satellite data. And if there's a common format for that, that would make it more easy for us. And of course, also training to the emission inventories of all the countries is needed to understand the use of satellite data and how we can compare this with the emission inventory data, as it's quite complex and it's quite different to what we normally do. So we see there's a huge potential to use satellite data for comparisons with the emission inventories, especially for reconciliation purposes. And if it works well in the future, then of course it's also very handy to use satellite data for, let's say, more developing countries where not a lot of information is yet available. So it's a huge potential for that as well. But of course, there's also some discussion points. We think there's a huge discussion point in that we have to be clear on what we calculate in the inventory emissions, which is a very detailed level, versus what would be feasible by inversions. And besides that, also the lack of observational data could be a problem to make the whole overview. And next, at this moment, there are several communities on these satellite data projects. And the question is how to keep them aligned and so that it's also clear for the emission inventories what direction we should go. And besides that, it's also important to ensure cooperation after these projects are finished. So what do we do after this? That was my last slide. Thank you.
Thank you very much, Luz. So it was really interesting. I invite all speakers to switch on their cameras. Luz, one of these things that you were saying, they are amazing perspectives, really useful, because this is what we want to speak aloud as SEEDS project and to elevate to the European Commission. One of the natural places is really CAMS, and ensure that the different communities working with inversion modeling is finding out which is the right product and how this right product can be provided through Copernicus, which is the natural agglutinator, I don't know, a place where we can really find authoritative voice regarding all this. But I'm sure Leonor will want to step into it. We are running a bit short of time, so if you don't mind, I would like to go directly to the questions that we have to the audience, because we want to hear from the participants that are with us, and then I will be asking you, the speakers, to speak aloud your own answers, and then I will take that opportunity for asking a few questions also to Luz and Juan Antonio specifically, because it was really interesting insights that you were sharing. An icebreaker, so just start using when you so I see that you are connected and there, and yeah, we would like to know where are you from, and you can put either city, country, as you prefer. Yeah, Barcelona, obviously. Perfect. So We have up to 15 participants. We have more people connected. So if any of you is a bit late, please speed off and we will move. So we go to the next question, where we want to know about you also, which is the definition of yourself professionally, what best defines you. This is important because during this workshop preparation, we have been working hard to try to have stakeholders, to have practitioners, not only research voice, which obviously is important, but it's not easy. First, because each of us working on a particular company, sometimes we work more nationally based, so these general initiatives at EU level are less interesting. But well, I think we did our bit, and now we have 23% business people, and we will go back to actual questions about satellites. And this is for everyone. So if did you ever hear about the possibility of using satellite data to estimate it, and a bit of your perspective on it. And then I would like to ask Jose Antonio, if you remember at which point did the conversations about start using satellite information for your product started?
Mm-hmm.
If it was easy at the beginning or if it was a bit challenging. Of course, now you have shown data, so now you have done it, but how it was the process?
Yes. At the beginning was so difficult because we don't have any experience on that. We started in a Eiffel project, that is a research and development Horizon 2020 project. Now I can say that we are experts because we are having some problems with the last update of Copernicus data space that has changed the way to retrieve the information the 1st of November. But yes, at the beginning was a challenge, and now we are trying to do our best and try to improve the catalog of different options in our digital twin.
Good. And in your case, Michael? So what would you say is like, it's fine, I have used it, but it was difficult?
I considered but did not use. So that was I explained before. So whatever we use, it needs to be already processed and ready to be easily digested, because we don't have like the resources to do offline processing, and it's like 6 cities across Europe, and we need the same exact data in order to be comparable for the same years. So that's why I considered, but I did not use it yet.
No, that's perfect. I didn't say, but all of you, please feel free to jump at any moment you want to raise a point. So don't wait for me to let you come in. This was one of the main answers that we expected, and that's why Thais was providing this inspiring talk, because it's not easy. Once the information is there, we know it is there, we see the potential, but it is not always easy to do this step into having an actual product. And that's why these type of conversations today are important. Then, in general, to understand the type of problem, not necessarily related to satellite, but which are the type of emissions that could be more interesting to you. So yeah, so far traffic-related emissions for sure, a bit of biogenic. So this was a surprise for me when I started working in SITS, understanding how not also an important factor. And then I wanted to ask Luz, quite with inventories, in order to assess better the emissions related to natural sources. Have you experimented a bit with it in the Verify project, or which is your perspective on the use of satellite for biogenic emissions?
I think it's very useful, because it gives just an extra insight, let's say, to compare with what we calculate so far. But in the Verify project, mostly focused on greenhouse gases, so methane and carbon. We did not really come to the point of viewing about these kind of emissions. But it makes it indeed difficult because the satellite data has the natural emissions, but we exclude it also in some calculations. So it's always difficult to compare.
Yeah, it's a challenging challenge that we have in front. I think this is also an opportunity to see which are the next steps on research needs. Then Juan Antonio, also related to your presentation, a question I wanted to ask you. You were talking really interesting about this maritime transport, so also the emissions between one port and the other. Besides this, is this something that only a few ports are interested, or is it there's a general interest in ports? And then together with this do they also care about the difference between the emissions of the actual ships, but also the emissions of the logistics within the port, all the trucks, movement of the material? And how do you think, which is your perspective on what ports think?
So regarding the first question, I think that I'm sure that this is something new for the ports. When I made a presentation about that, the ports are very interested on how we can solve the problem to monitor the different pollutants, not only air quality, also, for example, water quality. Because if they don't have any IoT sensor or any other option to measure the pollutants for them, this is very attractive. For example, a real case. In other European project, we have monitored the water quality using satellite images from Copernicus Marine. So in that case, the port doesn't have any kind of sensor to monitor the water pollutants, as for example, chlorophyll, suspended matter, or seawater turbidity. And for them, it was very attractive, and they are using our tool to monitor this kind of pollutants. And the second question, could you repeat the?
Is if people if your clients in ports, they are also interested in understanding differences between emissions by all the logistics within the port and the ships themselves. You know, there are a lot of trucks moving material over the port, or it's not that relevant for them now.
Also, sorry, there's a question in the chat that could complement this one for Jose Antonio. It's what do you think is more relevant to your digital twin, the satellite column data or air quality concentration and emissions from the services?
Okay, I have read the question from Leonor. Okay, so the first one that's asked Isadora. So now the ports are very conscient about they have to study the different actors that emit the pollutant. So, for example, other module that will have the digital twin is an option to calculate the specific emissions per each vessel. So they are very conscient about that, and they want to differentiate the emissions per each specific actor. I mean, trucks, vessels, and their operations. Many times this is not possible, and it is very complicated. And obviously, it is impossible to calculate or to distinguish that using satellite images. This is obvious because it is very related with the size of the pixel. Regarding the question of Leonor, what is more relevant, the satellite column data or the quality concentration? Okay, I am not an expert on environmental aspects to have a clear answer on that. But for example, in the specific Eiffel project where we are working with the Balearic Port Authority, we are depends on what they want to measure. I mean, for example, the satellite, the tropospheric column data, so data coming from Sentinel-5P, it's a column, so it is not possible to work with that information. We can use that information to, for example, calculate predictions. It's only a measurement in a specific point. It's like different layers. It's like the Earth, different layers. So obvious, but we are using that to measure, as for example, NO2, SO2, and ozone. In the case of CAMS, they have a specific data set that give us predictions for the next 24, 48, and 72 hours, and in a sea surface and in a sea level. So this is very relevant for the port. And for example, we are using that results, so that predictions, to compare the same predictions that we are that we have calculated or developed using in situ data. So data coming from IoT sensors to obtain or to compare the accuracy of the results coming from CAMS and the in situ data.
No, that's perfect. I want to
Mhm.
highlight, particularly because at Lobelia we are involved with KNMI in a project for the European Space Agency, specifically to work with Tropomi data to disaggregate these columns. So that's why we say this is a future and forward-looking workshop, because what it is not possible now might be possible in half a year, in 1 year. So it is upcoming, and as we know, with technology, everything evolves. So the other question I'll ask everyone is the one that is more relevant. And then I wanted to ask Michael, because one thing that you were saying, I think you were saying on the chat, was really interesting, is that importance that even if you work at the local scale, that you wanted information that you could be providing and showing for a number of ports and homogeneously. So how important is it for you, this homogeneity, or being able to show similar information for different ports?
Yes, they're important because we want everything to be available in each city for people to be ordered to compare. So if the pollution is in a given city, if it's comparable to the other one, or what? So we need to have the same data and at the same time frame also. It's very important for everything to be as homogeneous as possible for us to work with.
And this comparison aspect, or this comparison need, it is for benchmarking. It's because what is the main purpose of? I mean, I see the purpose overall for comparing, but which is the final value for these port cities to being compared with other, in order to improve in the future?
Yes. So basically, if you only look at a given year, pollution, an hotspot of pollution, it might be worrisome, but it's not that meaningful for what we do. So we want to know how is the trend progressing. So is the city becoming more polluted, or even if it's already polluted, it's the pollution decreasing? So we are more interested in seeing how the evolution has occurred in the last couple of years, rather than just to look at the hotspots and say, here is an hotspot. So we are more interested in the evolution of over a number of years. That's why.
Thank you. So the next question is the brave one, because I know it's difficult to write it down, but we wanted to ask if any of the participants is willing to write that if you could have an operational estimation of emissions from satellites, what would you use them for? Which is your main, and you can be as short or as long as you want. So it's up to all of you. And let's see, I don't know, while we wait, if someone is wanted to write something. Thais, if there's any relevant question in the chat.
Yes, we have
like
one question for Luz.
Sure.
It's from Leonor. She is making a question about what does she think about the SEEDS portal with the new ZAR format?
Yeah, I must say that I haven't tried using it yet, but what was explained during the session, it looked very good. And I think it can be very helpful for us to have these kind of data. It will be quite complex though, because it's for us, we're still figuring out how to exactly compare the data. So what is missing, what is included, etc. But I think as especially as we are going to hire someone in our team and busy with inverse modeling. We're gonna dive into it for sure.
Thank you very much. Is there any, if not, we are gonna move because as we are approaching
Yes,
the time.
we can move.
So what type of estimates from satellite-based products would you be useful for you? Near real-time, historical data, or both? That's good. I will wait a bit. So in general, the more information, the better. I'm going to be moving a bit faster because I would like to finish. There are only 2 more questions. Then is the questions about what temporal resolution could be most useful for your needs. Is either having average that are provided weekly, annual, monthly. Perfect. I know these are the usual questions, but they are still relevant, and particularly when we talk about tailoring products, is really understanding which is the direct need to hit. Okay, and then we go to this final question. So is what type of access to the data would be preferable for you? And here we have different options, and we understand they depend on the purpose, level of experience using satellite data, etc. And here, while people answer, I'd like to ask Jose Antonio about how do you see here when we ask these options on how to deliver information? You are here representing a value creator, you know, a company that's provided is getting even closer to the final user. And how do you see your role as this intermediary, or do you still need intermediaries for yourself to provide you the data and then you provide it? Do you see it as a chain?
Yeah, I think that we are the provider because in the end our solution is able to show in as it was a end user the results, or in that case the satellite images. So it has the option to load or to activate or deactivate the different layers. We access to the different options, to the different APIs to retrieve that information. So we are a provider that offers the solution to the end user.
And do you see yourself going directly to CAMS or to a data provisioner, or do you think that it could be also helpful for you to have someone helping with tailoring further the data
Could be
before
helpful
you
to
provide
have someone that has probably more knowledge, not about how to retrieve the data, but to know the different options that are in the market. I am talking not about free options, also commercial options, so pay satellite images, because some of them it's very complicated how to obtain information, and it's it highlights the lack of information about how to work with them.
Mm-hmm. And Michael, from these options, is there anything that you want to highlight? Where do you see yourself?
Yes, so I would like to download the data, not necessarily for offline processing, but the important thing will be to do in order to be able to download the data, even if it was using an interactive web-based data viewer and then selecting the area to download.
Mm-hmm. In her presentation, Luz was also highlighting the need for more information. And then Jose Antonio was saying the same. Maybe someone who knows a bit better to give some expert advice is also the case for you? The need of more training, capacity building, or accessibility to experts that help you understanding a bit better the satellite product?
Yes, of course. If that will be a resource that will be available on the market, yes, of course.
Okay, and Luz? Which is your case for this type of data access? Which would be your preferred options?
I think that the download for the data is is very useful, because then we can make comparisons ourselves in our own programs we use, and also the API would be very welcome.
Perfect. So it's 1 minute to 12, but for all of you or any of you who wants to stay or can stay, I want to give the floor to Leonor to make a bit of a wrap up of the session. But before, I want to thank our panelists. Thank you for your time, your perspectives, and the discussions. And they are really useful for us, and I hope that also for all the attendees. Leonor?
Yes, thank you, Isadora. Thank you very much to Lobelia for organizing this. And I think it's been a workshop today that it is not really working on the seeds products. Most of you have received the invitation for our General Assembly, where you'll hear more about seeds and all the questions that it's been in the chat to me about the seeds products. Just join us on the 5th and 6th, and we will follow on the seeds products. But today was really the time where we really appreciate having talked to these end users. So yeah, they really appreciate the panelists. And what I think it's one lesson learned from today is that most people have been answering on the satellite information. We have considered using it, but we have not done it yet. And this is a place where we are now. We are still considering, we want to see what are the capabilities. And it's been very useful to hear that most of the people that have been using it, even through projects. That's what Lois was saying also, that we work in projects like Seeds, like Verify, like Usage. We will use projects of the European Union to get into understanding better this data, understanding better how to benchmark, how to use it, what is valuable, what is not. And this is something that I think it's an important part to look at now. How are we going to keep track of those projects and the data that is there? One of the things we've been working in SEEDS is that this portal has to continue. We've done it in a way that Lobelia has been very broad looking, maybe seeing how it can go into CAMS. And it's really very interesting for the satellite data that we have the CAMS services where the data can be translated to the users. And one of the things I've seen is that the intermediate providers is still not very well recognized there, but we need them because this satellite data coming as a column is not the emission data that Michael needs in his port. And we need to really get into this understanding of how the value creators, the intermediates that will convert the data from the CAMS services into the users are necessary to continue developing. And I hope that we have more and more of building a community on it. So I appreciated very much this collaborations request from Lois and the possibility of seeing how projects can be kept alive and the data can be kept alive for analysis in the future once the projects end. Of information that is there, and maybe asking value creators like Lobelia can come to the use of the end users. This is really where we need to continue thinking, and there is a very large well of information that we can work on. Just a final comment, which was very interesting. Most of you said that if I had emission data from satellites, I would like to have it annual. And that's surprising for us in SEEDS after the analysis of the data, because we saw that one of the largest values of the satellite, the monthly and weekly variations that we could get from it. So it was really this added value that to the community, really only benchmarking the annual, but we have a very interesting way of analyzing also variations on the temporal that can be very relevant when we look at health health impact and that system will need to continue. So that's a bit from our part. It was really very useful. We have some recommendations from you, interesting for the future analysis of products that are getting European Union. I hope it has been useful for all of you to hear a bit more and reflect a bit more on the use of satellite data for emission constraints in different areas in Europe. So thank you very much.
Thank you very much, Leonor. And with this, we finish our workshop. Thank you very much to all of you. Thank you.
Thank you.